Hello everyone. We have a question which says that four coplanar forces of magnitude 40 Newton, 20 Newton, 50 Newton and F Newton act at a point in the direction shown in the diagram. What are coplanar forces? Coplanar forces are the forces which act at a single point. If we just look at the diagram, these four forces, the F Newton, 40 Newton, 20 Newton and 50 Newton, they all are acting at this particular point. Therefore, all these four forces are called coplanar forces. The condition that they have given to us in the question is the four forces are in equilibrium. Find the value of F and alpha. F is the unknown force and alpha is the angle. We have to find the value of F and alpha, and the condition that they have given us is an equilibrium condition. So very easy. In order to solve the questions related to equilibrium, just split up them into components, the horizontal and vertical component, and just equate them like by using the opposite forces as equal. So I mean the opposite horizontal forces as equal and the opposite vertical forces as equal, and just solve the two equations, get the value of the unknown. But before that, we should understand the components, because I have seen that most of the students have misconceptions that the horizontal component is always a cos component. It is not like that. For example, if this is an angle, that means this is an angle theta or alpha or beta, whatever it is, the side next to that angle would be a cos component of that particular force, and the opposite side would be a sine component of that particular force. But if the angle is over here, that means now the side next to this angle would be a cos component side of this particular force, and the opposite side would be a sine component. That means it is not always like a horizontal force is a cos component. No, it is not like that. By looking at the diagram, we could easily split them up into horizontal and vertical forces. If we just look at 40 Newton, we have a 60-degree with the horizontal. That means 40 cos 60 would be horizontal, and the vertical would be 40 sine 60-degree pointing upward. For this 20 Newton, this 30-degree is with the x-axis, I mean the positive x-axis. So 20 cos 30 is the horizontal component and 20 sine 30 is the vertical component pointing downward. Similarly, for this alpha, this particular force F, the horizontal component would be F cos alpha, because the angle alpha is with the x-axis, F cos alpha, and the vertical would be F sine alpha. And for this particular 50 and 45 degree, because the 45 degrees again with the x-axis, so 50 cos 45, and the vertical component would be 50 sine 45. So we have split it up the forces into horizontal and vertical, and the condition is an equilibrium. So we could solve it through the horizontal forces, opposite forces are equal, and vertical opposite forces are equal. So if first of all, if we just look at the horizontal forces, we can see we have two forces over here, 40 cos 60 and 20 cos 30 degree. Both are pointing in this direction. F cos alpha, 50 cos 45, both are pointing in this direction. That means the sum of these two would be equal to the sum of these two, because the condition is an equilibrium. So F cos alpha over here plus 50 cos 45 over here equal, because equilibrium, equal to 40 cos 60 over here plus 20 cos 30 over here. 40 cos 60 plus 20 cos 30, and then moving this 50 cos 45 on the other side and subtracting it, and then after simplifying all these, we have 1.965, and that would be equal to F cos alpha, which is our equation 1. Similarly, if we just look at the vertical forces, we can see two forces are pointing upward, F sine alpha and 40 sine 60 upward, and two forces are pointing downward. That means the sum of these two would be equal to the sum of these two. That means F sine alpha plus 40 sine 60, f sine alpha plus 40 sine 60 would be equal to, because equilibrium, would be equal to 50 sine 45 over here and 20 sine 30 degree over here, and moving this 40 sine 60 on the other side and subtracting, and after adding these two and subtracting this, simplifying, we have 10.714, which is equal to f sine alpha, which is our equation 2. Our target is to find the value of f and alpha. We have two different methods. Both are very easy. You can apply any one. The first method is dividing equation 2 by 1. That means dividing equation 2 by 1. So f sine alpha divided by f cos alpha would be equal to 10.714 over here divided by 1.965. After dividing, cancelling the value of f, sine upon cos is 10, and then taking the tan inverse of the answer of this, which is 5.45, we have the angle alpha, which is 79.6. So we have found one of the value. You can place this value in any of the equation, whether the equation 1 or equation 2. For example, if we take equation 1, f cos alpha is equals to 1.965, because we have the value of alpha, so we can divide this cos alpha below 1.965, and after solving it, we can easily get the value of f, which is 10.9 Newton. We do have another method also, that is squaring and adding equation 1 and 2. Again, very easy method, squaring and then adding. So first of all, we have to square. That means f cos alpha and f sin alpha, first of all square them and then add them, and similarly 1.965 and 10.714, square them and add them. After squaring and adding, we have 118.65, and after simplifying these bracket, we have f square cos square alpha. From here we have f square sin square alpha. Taking f square as common, we are left with cos square alpha plus sin square alpha, which is an identity equal to 1. So we are just left with f square equal to 118.65, taking the square root, and we have the value of f as 10.9 Newton. And this is definitely the same answer that we got from the method 1. Now placing this value of f in any of the equation, whether 1 or 2, if we take equation 1, f cos alpha is equals to 1.965, placing this value of f 10.9 over here, then dividing that over here, getting the answer, and then finally taking the inverse, cos inverse of that, the answer is the angle, which definitely is the same that we got from method 1.